The three equations that create parabola are the standard form, vertex form, and index form. The standard form is y equals ax squared plus bx plus c, where x and y is the coordinate, and c being the y-intercept of the graph. The vertex form is y equals a parentheses x minus h parentheses square plus k, where h and k is x and y of the intercept, or the maximum or minimum point. And the y-intercept form being y equals a parentheses x minus q parentheses x minus p parentheses. The topic that I'll be focusing on is a parabola created when throwing a football towards someone else. As everyone knows, a football thrown in the air will form a parabola since the ball would arc downwards after being thrown for a while. In a real-life situation, a football throw is an essential part to the game of football. Being able to correctly estimate the landing spot of the football might be able to change the outcome of the game. Therefore, by using parabola, we can accurately estimate the motion that the football would follow when thrown into the air. This is the actual footage of me throwing a football towards my partner. By plotting the grid, we can find the equation of the parabola. The equation I found was y equals negative 1 over 24 parentheses x minus 8.1 parentheses square plus 4.8. As seen from the picture, the parabola represents the flight path of the football thrown into the air. To find where the football landed, or the x-intercept of the model, if the equation is in standard form, we will first need to find the axis of symmetry, or the maximum point, or known as the vertex. By using the formula negative b over 2a, we can find the axis of symmetry. Then using the resource to substitute in the values to find the value of vertex. However, right now the equation is in vertex form. Therefore, these steps are unnecessary since the value of vertex can already be seen. The value of vertex is 8.1, comma 4.8. Since in vertex form, h and k represents the value of x and y for the vertex. The first solution is to change the equation from vertex form into standard form using the same numbers from vertex form. Then factoring the x in standard form and use the principle of 0 to solve for x. Remember that this might give you 1 to 2 answers. However, referring back to the context of the question, use the one that fits the content the most. In this context, we would use the one that is positive and not negative, because when throwing the ball would go forward, not backwards. In order to change from vertex form into standard form, first FOIL out x minus h squared, then distribute whatever a is into the parentheses. After this, simplify. With this done, the parabola should be in standard form. After having the standard form, the value of standard form can be filled into the quadratic formula, which can be solved for x-intercept. The third method is to use the quadratic formula. This method should be kept last since it is used as a last resort after all other methods have failed, or that the numbers are just decimals or fractions and it is a pain to deal with when factoring. The answers I found were two x-intercepts. One, negative 2.6, 0, and 18.7, 0. Both are rounded to the nearest tenth. And since the context of the problem is throwing a football forward, it is practically impossible to throw a negative distance. So the only answer is 18.8. In order to graph the parabola, we need to use certain elements of the vertex form equation, such as its a and hk point or the vertex. The a would determine whether it is a concave up or down, and whether it is wide or thin. The hk point or the vertex would determine the graph's maximum or minimum point. In this context, it is the maximum point since it is looking at the maximum height the ball would achieve before falling down. The scale of the grid is 1 meter per 1 square. As you can see from the graph, the release point of the ball was around 1.9 to 2 meters. Since I am 1.8 meters tall and threw the ball over my head with the addition of my arm length. The football traveled a distance of 18 meters, landing at my partner's feet. The maximum point that the ball reached was 4.8 meters in the air. This was 1.8 meters away from the release point. Please do keep in mind that this is all an accurate estimation, since decimals and rounding were used in the process of solving the equation. and that the actual distance between me and my partner might not exactly be 18 meters, but something similar to 18 meters.